We will discuss answers for some questions related to titration and organic analysis for chemistry practical Viva. And the very first question is what is titration? So you have done titration where your K-manophore and the more salt are treated with each other, and this is the apparatus that you have used. So in titration we have two solutions. Concentration of one solution is known and concentration of another solution we have to find out. We take fixed amount of or volume of one solution in conical flask that we pipette out, and then we add another solution into the first solution from the burette dropwise, and the end point will be the point where the reaction between the two substances is complete. In this case, we are not using any indicator, but here since K-manophore itself is colored, therefore it will be very easy to find out endpoint with slight excess of K-manophore, which gives light pink color. Okay, so titration we define process of adding one solution from burette, this is burette, to another in the conical flask, and the one which we take in the conical flask, we take fixed amount of this with the help of pipette in order to complete the chemical reaction involved is known as titration. So here chemical reaction involved here is the redox reaction or oxidation reduction reaction. One substance is oxidized, another one is reduced. Second question, what is standard solution and how it is prepared? In your practical you have prepared a standard solution of more salt. Okay, so why we are calling it as standard solution? So a solution with a known concentration that is used to find out the unknown concentration of another solution. Okay, so in this case you have prepared in your lab solution of more salt by weighing the salt and then making the solution. So you know accurate concentration of this solution, and with the help of this you have determined the solution that is your K-manophore solution concentration. Okay, so therefore your more salt solution was the standard solution. Or we can define in another way, a solution whose concentration has been accurately determined. How we determine? Because you have prepared accurately by taking all precaution, avoiding any error while weighing as well as while preparing the solution in lab. And these are the steps for preparing any standard solution. Here I have given you the common steps. It is applicable in all cases, but depending upon the type of titration, some changes or some additional substances are needed in different cases. Like for example, in few cases we have to heat the solution because substance is not very soluble. Sometimes solubility is increased by adding any dilute acid. Sometimes some substance we have to keep in a specific form, therefore we add an acid. So therefore in particular case we do slight changes, but these are the main common steps to prepare any standard solution. So whatever concentration we need for any solution or standard solution, we do the calculation and accordingly we weigh the mass of solute needed for desired concentration. After this, when we have weighed with the physical balance, then this substance which we have weighed accurately without any error, we dissolve this in a small amount of water in a beaker, and after shaking once we have got a clear solution, then we transfer this to volumetric flask. Now we have different volumetric flasks. These flasks are the standard flasks which are having some fixed volume, and they are having also final marking for that total volume. So therefore depending upon which flask you are using, according to that you will be preparing the solution of a given volume. After this we bring the liquid to the mark given in the volumetric flask. So to do so we have to add water or a solvent. After this we shake and then we store. So this is how we have prepared standard solution in lab. In case of the solution of more salt that you have prepared in your lab, you have added sulfuric acid also to avoid hydrolysis of ferrous sulfate. Okay. What is the difference between standard solution and stock solution? Standard solution already we have discussed. You are clear about that. So a standard solution can be made from a solid solute by using volumetric flask. Okay, so all those substances which are of high purity, from them after weighing by following these steps, we will prepare the standard solution, and we know the concentration of standard solution accurately. But in few cases, few substances are not stable or they are not of high purity. Therefore, in those cases, we cannot prepare standard solution by in this way by following these steps. So in such cases, what we do, we prepare a concentrated solution in large volume that we call as stock solution. Now this from this stock solution, we prepared a solution of desired concentration by adding more solvent. Okay, so volume and concentration of this the new solution which is prepared before and after dilution, we can find out by this formula. Okay, so like for example, sodium hydroxide solution accurately we cannot prepare by weighing. So what we do, we prepare sodium hydroxide solution from a given stock solution by adding more amount of water. Okay, so what concentration we need, that is this C2, and what is the initial concentration, accordingly V1 and V2 are taken. Okay, so stock solution is what that concentrated solution from which you can produce more dilute solution. Okay, what are the two types of standard solution? Now standard solutions are also of two types: primary standard solution or primary standard, and secondary standard solution or secondary standard. So what is primary standard? Primary standard is that reagent which we can use to dispense or to distribute an accurately known amount of analyte. Analyte is the substance for which we are doing identification and we are measuring the concentration. Okay, that unknown substance. These are the solutions of substance of high purity, and these are used to find out the unknown concentration of a solution that can undergo a chemical reaction with the primary standard. Okay, so those solutions which can undergo any reaction with primary standard, for those solution we can find out the concentration of substance present in them. So the solution which are used to find out concentration of unknown substance in a given solution, these are called as primary standard. Okay, like for example, your more salt solution was the primary standard. Now secondary standard. Now secondary standard solution is a solution which is we prepare specifically for a certain analysis. Like for example, as we discussed in case of sodium hydroxide. Sodium hydroxide solution we cannot prepare accurately or we cannot avoid error while weighing and preparing solution. Why? Because sodium hydroxide is hygroscopic in nature. Whenever it comes in contact of open the air or atmosphere, it will absorb moisture and it will convert into liquid. So therefore lots of liquid will stick to the watch glass in which you are weighing, or some will stick to the edges of your flask also, or beaker in which you are preparing the solution. Therefore what we do, we prepare secondary standard solution in such case. For example, sodium hydroxide is to be used as a secondary as a standard, then it should be used as a secondary standard, not the primary standard. So what is the meaning of that? So in this case, for secondary standard, it is a substance whose active agent content has been found by comparison against a primary standard. So sodium hydroxide solution is prepared, and its accurate concentration we will find out by titrating it with, or by doing analysis with any weak acid, that is the acid base titration, and we will know the accurate concentration of sodium hydroxide. Then we can use it as a standard solution called as secondary standard. Okay, so sodium hydroxide cannot be used as a primary standard because of the hygroscopic nature. Therefore first we prepare solution of sodium hydroxide, then we will standardize it with the help of some other reagent, After calculation, we will get its indirectly its accurate concentration. What type of substances are suitable to prepare primary standard solution? As we discussed, primary standard solution are those solutions where we know the accurate amount of substance being dissolved in a given medium or a solvent. So these are the primary standards are non-toxic, they are easily available, they are inexpensive, they have high molar mass. Why high molar mass? Because when you're weighing, if molar mass is very low, for a given number of moles, we have to weigh a very small amount of substance, and accurately finding the mass with physical balance for a very small amount or for a small mass is very tough. So for convenient weighing, or so that you can find out the accurate weight without any error, it is better it should be of high molar mass. Okay, it should be stable, it should have high level of purity, that is no impurities are present, and it should be non-hygroscopic, like it should not be like sodium hydroxide, because sodium hydroxide was hygroscopic in nature. And it should have it should not have any water of hydration. And the examples are sodium carbonate, that we call as soda ash or washing soda, potassium dichromate, that is K2Cr2O7, potassium iodate, that is KiO3, and oxalic acid, this is a weak organic acid. So these are the substances, they are very stable, and these are having most of these properties, therefore they can be used as a we can use them as a primary standard. Okay, so whenever we prepare solution with these substances, their solutions have a particular concentration that we know accurately, and that we have determined ourselves by weighing and making the solution without any error. Now give example of secondary standard solution. We discussed secondary standard solution are prepared indirectly by finding their accurate concentration from some other means, that is we will find out their concentration accurately indirectly. We cannot weigh them and prepare their solution directly. So these are the substances which are not stable, which are very reactive, therefore it is not easy to prepare their solution directly. They are hygroscopic like sodium hydroxide, and they are impure sometimes. We cannot avoid impurity, or we cannot have a substance of high purity, therefore such type of substances, when they are to be used as a standard, they first their accurate concentration we have to find out indirectly with some other substance, which is mainly primary standard. So primary standard solution is used to find out accurate concentration of a secondary standard solution, which we have to use in a particular case. Okay, what is more salt? You have used more salt in your titration, that is redox titration. And what is more salt? So this more salt is ferrous ammonium sulfate. It is a double salt, and don't get confused with the coordination compound. It is not a coordination compound. When we dissolve more salt in water, we will get all respective ions, that is free ferrous ion, and your sulfate ion and ammonium ion. All ions are available in the solution, therefore it is a double salt, not a coordination compound or a complex compound. And it is prepared by mixing ferrous sulfate with your ammonium sulfate. Okay, and the shape of the crystal, when we mix these two and then we crystallize the double salt from the solution of this mixture, we will get the monoclinic crystals, and the solution is slightly acidic. Why? Because of the presence of ammonium ion. And when we prepared the solution, we add sulfuric acid. Okay, you must have prepared sulfuric acid. So sulfuric acid is added to avoid oxidation of your ferric ion. Okay, because here iron should remain in +2 oxidation state, that is ferrous state. But you know that more stable state for iron is +3, that is ferric state. To avoid oxidation from +2 to +3, we add some amount of sulfuric acid. Okay, now used as this more salt solution, it is used as a reducing agent. okay, and it is used in the production of ink, dyes, pigments, and also it is used for plant as a fertilizer. Now, color is light green or blue green type of shade is there, and molecular mass, you should remember, molecular mass is 392 grams per mole. Please be specific about the unit. Don't use only grams, because whatever molar masses are there, they are for 1 mole. Therefore, always unit used is grams per mole. And the oxidation number of sulfur is +6. So it should be clear what is the oxidation number. Now next is, what is self indicator? Okay, the titration that you have done, that is, you have titrated your more salt solution with potassium permanganate solution. So in this case you have not added any indicator. Why? Because your potassium permanganate solution is colored. Okay, so if either titrant, that is your standard solution, or a solution where concentration is known, like more salt solution, or titrate, or substance for which we are finding the concentration, or which is unknown for us. So either the known solution or unknown solution, if any one of them has its own color, that then it can be used to detect the endpoint. Okay, and therefore your potassium permanganate, which is colored, that is dark pink or purplish color. So when we do this titration, this potassium permanganate, your permanganate ion will be converted to manganese ion, Mn2 plus ion, which are colorless. Okay, so the when all potassium permanganate is used, then solution from pink or dark pink, it will turn to colorless. Okay, and even if we add a 1 drop of extra potassium permanganate, or we have a slight excess of potassium permanganate, then we will get a very light, nice pink color, as which is the indicator that all your reaction, that is oxidation reduction reaction or the redox reaction, is complete, and now potassium permanganate is in slight excess, that is, it is unused. And it is this, since it is your indicator is present as one of the reacting substance, so it is also called as internal indicator. Okay, next, what is external indicator? As we discussed, if we are not adding anything from outside, we call this self indicator as internal indicator. But in some cases, your titrant as well as titrate, that is both reacting substances, or you can say your known and unknown solution, both are colorless, and their end product is also colorless. So we cannot find out the end point. In such cases, we have to add an indicator which is having different color in different medium, or which have a specific color in a given medium. So therefore, one of the example is phenolphthalein, and another one is methyl orange. Like when we have acid base titration, for example, we are having titration between sodium hydroxide and oxalic acid. So in that, or sodium hydroxide or acetic acid. So when we have acid base titration, in that case we use phenolphthalein as an indicator to give the end point. So mostly the external indicator, they are having a color in a given particular type of medium or under specific condition. What do you mean by titrant and titrate? Okay, this term already we have used. So titrant, the solution for which you have your concentration is known. So the substance which is present in this known solution is called as titrant. And in case of unknown solution, whatever substance is present for which we do not know the concentration, that is called as titrate, and solution is known as unknown solution. Okay, so the reagent or a substance whose solution is used to find out concentration of unknown solution is called as titrant. Like in your case, more salt solution was titrant. Okay, and titrate, solution consisting the substance to be estimated, is termed as unknown solution, and the substance which is present in this is titrate. Like potassium permanganate solution is unknown solution, and potassium permanganate present in this is titrate. Okay. When we are doing titration, endpoint, what is endpoint, or where we have to stop the titration? So here is the next question related to this. What is equivalence point, or it is the same as endpoint? Equivalence point, the point at which the reagent, that is titrant or the known solution, and the substance that is titrate, which is for which we are finding the concentration, are chemically equivalent. Okay, both are equivalent to each other. So that or the point at which the reaction has stopped. For example, acid has completely neutralized the base, or oxidation reduction process is complete. So that point is called as equivalence point and or end point. At this point, number of equivalents of titrate is equal to number of equivalents of titrate. Okay. Question is, what is the difference between molarity and strength of the solution? For the titration that you have done in lab, you have reported your answer in terms of molarity and strength of potassium permanganate solution, which was unknown for you. So what is this molarity? Molarity is the measure of number of solute particle in a solution. And this number of solute particle we write in the terms of number of moles. While strength is a measure of total amount, that is total mass of solute in the given solution. So we write formula of molarity as, which is represented by capital M, number of moles of solute divided by volume of solution in liters. And the molarity we can rewrite in terms of, if we split this number of moles of solute. Number of moles of solute is mass of solute in grams divided by molar mass in grams per mole. So this is molarity. Now strength. Strength is given in terms of grams per liter, that is mass in a given volume. Therefore, mass of solute in grams and volume in liters. Now from this equation number 1 and equation number 2, we will get this equation, that is molarity is equal to strength divided by molecular mass of substance and or molar mass in grams per mole. So how we have got there, have a look here. This in the formula for molarity, mass of solute, this divided by volume of solution, this is nothing but strength divided by molecular mass of the substance. So strength divided by molecular mass will give you the molarity. We will rearrange this equation. So we'll get strength of given solution grams per liter is equal to molarity of that solution multiplied by the molecular mass of that solution. So simply, if molarity we multiply by molecular mass of the substance, we will get the strength of that particular solution. And in lab, whatever solutions you are using, mostly their molarities or normalities are given. So in that case, you have to use molecular mass to find out the strength. Next question, this is from organic analysis. You have different organic compounds for identification. So first question, what is Molish test and how it is done? So Molish test is a general test for carbohydrate. Okay, and how you have to proceed, the very first step, first we have to take a small volume of the sample solution, that is whatever sample is provided to you, you will make a solution of that, and that solution, small amount of that solution you will take in a test tube. Now in this solution, you will add 2 to 3 drops of Molish reagent, and then you have to shake. What is Molish reagent? Molish reagent is prepared by mixing 10% alcoholic solution and alpha naphthol. Okay, so alpha naphthol plus alcoholic solution will give you what we call as Molish reagent. Now after adding Molish reagent, we will shake these two. Okay, the sample solution and the Molish reagent, we will shake them, mix them nicely. Then from along the side of the test tube, drop wise, we will add concentrated sulfuric acid. When you are adding sulfuric acid, be very careful and do not add too much of sulfuric acid. Okay, so slowly, gradually from the side of the test tube, add sulfuric acid. If you are adding sulfuric acid in the bulk, and directly in the solution, you will not get the result. Therefore, with the help of dropper, drop wise you add sulfuric acid, and sulfuric acid should first touch the side of the test tube, not your solution. Okay, after adding sulfuric acid, what you will see, two layers are formed, and you will get a violet ring or the pinkish ring or purplish ring at the junction of the two layers. Okay, your sulfuric acid is a liquid of high density, therefore it will form the lower layer, and just above the acid layer you will be getting a violet ring. Okay, such type of ring will be obtained. So, and this is the acid layer. Fine. So this is positive test for carbohydrate. If you get such type of result, that means carbohydrate is present in the given sample. Okay, now this is a common test or general test for carbohydrate. Therefore, the given sample, it may be a monomer like glucose or lactose, it may be a dimer that like sucrose, it may be a polysaccharide like starch. Okay, so it may be any. So which one have been given to you, you have to do specific test for that type of carbohydrate. So it is a common test for all. And what is the reaction? Sometimes this question has been asked, that what is this violet ring in case of Molish test, of what substance it is made up of. So what we have, when we in the given sample, when we are adding your Molish reagent and sulfuric acid, so your sample, that is carbohydrate, first react with concentrated sulfuric acid, and it will form either fulfural or fulfural derivative depending upon what type of carbohydrate you have taken. Okay, so this fulfural derivative or its derivative, it will react with alpha naphthol. This is alpha naphthol. Remember the formula of alpha naphthol, two benzene rings are fused and there is one alcoholic group, that is phenolic group, on one of the ring. Now this alpha naphthol will react with this fulfural or its derivative to give a condensation product which is violet in color. Therefore, we get this violet ring in Molish test. Okay. Next question, what are reducing sugars and how are they confirmed in a given sample of carbohydrate? Now, all carbohydrate that you have, they can be categorized into two broad category, reducing and non-reducing. Okay, so we have a specific test for reducing sugars. So the reducing sugars have OH group attached to the anomeric carbon. What is anomeric carbon? In case of different carbohydrate, when you write down the structure, so the carbon to which aldehydic or ketonic group or the carbon which is the aldehydic or ketonic carbon, that is which is the functional group carbon in the open chain structure, is called as anomeric carbon. You know that, like for example, for glucose you can write the cyclic structure as well as the straight chain structure. So in the straight chain structure, the very first carbon, which is functional group, carbon bearing the functional group, that is either it is aldehydic carbon or the ketonic carbon. So if this carbon is having one OH group attached, that is it is having hemiacetal structure, then this sugar is called as the reducing sugar. Okay, so reducing sugar, they have OH group attached to the anomeric carbon. Now since we are having OH group, so these sugars, they have free aldehydic and ketonic groups. So these sugars, they can reduce other substances. Why? Because this aldehydic or ketonic group itself will undergo oxidation. Okay, so they are very good reducing agent, therefore they are called as reducing sugar. So out of all carbohydrates, monosaccharide, all monosaccharides are reducing sugar. Why? Because they are having free aldehydic or ketonic group. And in case of disaccharide, only your maltose is reducing sugar, while sucrose, that is your normal cane sugar, is non-reducing sugar. Why? Because in case of sucrose, we are not having any free functional group which can undergo oxidation. Okay, so reducing sugars, therefore, they give positive Fehling test, they give positive Benedict test, and they will give positive Tollene's test. So first you will do Molish test. When you do Molish test, that means carbohydrate is there in your sample. That is, first you will identify the broad category. That is, you have to check whether it is carbohydrate, protein, or any lipid. So if you get positive Molish test, that means it is what you have, what you call it is carbohydrate. Then you will do the specific test, like you will do the test for reducing sugar to find out whether it is reducing sugar or not. So these three tests you can do to confirm whether the given sample of sugar is reducing sugar or non-reducing sugar. Okay. Next question. How will you confirm Fehling test and Tollene's test to confirm the presence of reducing sugar in the given sample? So it is the continuation of the previous question. So here, how will you do the Fehling test? First, your Fehling test. In your lab, you must have got, when you have done Fehling's test, you must have got Fehling solution A and Fehling solution B. Okay, or Fehling's reagent is not a single bottle. It is basically there in your lab in the form of two bottles. Out of these two bottles, one bottle is having colored solution, which is aqua blue in color, and another bottle is having a solution which is colorless. Okay, so this is your colorless solution. So what we will do, your Fehling's reagent is prepared freshly, and for this we will mix Fehling's A with Fehling's B. Fehling's A is mixed with Fehling's B to get you the active reagent, that is your Fehling's reagent. Okay, what is Fehling solution A? Fehling solution is nothing but, because it is having aqua blue color, it is a solution of copper sulfate and few drops of sulfuric acid is added in the solution. Okay, next one, Fehling's B. Fehling B is what it is, again aqua solution of sodium potassium tartrate, and some amount of sodium hydroxide is added. Now this sodium potassium tartrate, that is this one, sodium potassium tartrate is called as Rochelle salt. Okay, so you should know what is Rochelle salt. So your Fehling's B solution is basically solution of Rochelle salt and sodium hydroxide. What is Rochelle salt? So Rochelle salt is sodium potassium tartrate, and when these two are mixed, we will get the Fehling's reagent, and this is nothing but a solution of cupric ion, Cu2 plus ion. Okay. Now this Fehling's reagent is added into your sample, and then we will be heating in a water bath. We heat most of the solution for organic analysis in a water bath to confirm the uniform heating, and we do not do very strong heating. Otherwise, we can decompose any compound or we will not get the required result. Okay. So when we heat your sample solution with the copper cupric ion solution in the form of Fehling's reagent, after heating in a water bath, we will be getting red colored precipitate. And this red colored precipitate is the precipitate of your Cu2O, that is cuprous oxide. So in this reaction, what is happening? Your cupric ion is undergoing reduction to what? Your cuprous ion or cuprous oxide. This process is reduction, therefore sugar is called as, this sample is called as reducing sugar. It is bringing about reduction of your active reagent in Fehling's solution. Okay. So what is the basic reaction? Here we have given the open chain structure of the glucose, and this complete is nothing but your Fehling's reagent. It is having your cupric ion and the tartrate ion as well as sodium hydroxide, and when these three react after heating with the glucose, you will be getting sodium salt of gluconic acid. Okay, so here what is happening, glucose is undergoing oxidation. This is oxidation, and your cupric ion, they are undergoing reduction. Since cupric ion is undergoing reduction, therefore this glucose is acting as a reducing agent. Therefore these sugars are called as reducing sugar. So here copper is in +1 oxidation state, and here copper is in +2 oxidation state. Next is Tollene's reagent or Tollene's test. What is Tollene's reagent? Tollene's reagent is basically a solution of silver nitrate AgNO3 with sodium hydroxide solution and ammonium hydroxide. Okay, so what we do, first we will take silver nitrate solution and add sodium hydroxide solution in this, and after this you will be adding ammonium hydroxide dropwise. When we mix these two, you will be getting a precipitate, and after adding ammonium hydroxide dropwise, with this precipitate which is formed after the mixing first two, it will dissolve in the medium, and you will get a clear solution which we call as Tollene's reagent. Okay, so we will take sample in our test tube, that is aqueous solution of the sample. Again, always remember, for organic analysis, when your sample is dry powder, you have to make a solution as you have done in salt analysis. And in this solution, you will be adding Tollene's reagent, 2 to 3 drop, and then we will be heating in a water bath. After heating, when you are heating in a water bath, don't touch, don't shake the test tube. You have to keep this test tube still in the stand in the water bath, and after some time, what you will observe, the edges or the margins of the test tube will be shining like mirror. What we say, silver mirror formation is there. And what is this silver mirror? This silver mirror is nothing but what silver metal deposited at the inner lining of the test tube. Okay, so if you are getting a silver mirror formation, that means this you have got a positive result, and that means what, you are getting positive Tollene's test. So your reducing sugar is there in the sample. So what is the chemical reaction which is giving you this silver mirror, or how this silver mirror is formed? So these are the reactions which we will have when we prepare the Tollene's reagent. As we have done, Tollene's reagent is nothing but a solution of silver nitrate, and we have added in this ammonium hydroxide. So finally in the end, what you are having, silver oxide Ag2O, and this Ag2O will react with glucose. Your glucose will undergo oxidation, while your silver oxide will be reduced into metallic silver. So this is reduction. Why? Because from the +1 oxidation state, we are getting in 0 oxidation state, and here your aldehyde group is oxidized to carboxylic acid group. Okay, so this is oxidation. Therefore our sample of glucose is a sample of a reducing sugar, because it is reducing your Tollene's reagent. This is all how we are getting silver mirror. Okay, this metallic silver will be deposited in at the inner lining of the test tube. Next question, why do we take potassium permanganate solution in burette, not in conical flask? One thing always remember, that most of the time the normal pattern of doing titration is that your known solution is taken in burette and unknown is pipetted out in the conical flask. But in your titration, you are doing reverse. Your bore salt solution is the standard solution, therefore it is known solution. You are taking known solution in conical flask, while unknown is taken in the burette. Okay, otherwise normally, if possible, we try to take the known one in the burette. So why we are doing this reverse? The one we should take in conical flask, we have taken in burette, and the other one in the conical flask. What is the reason in this? The reason is that here potassium permanganate is acting as a self indicator. As you know, it is an internal indicator. So if we take potassium permanganate in the conical flask, like for example, because it is unknown, so it should be in conical flask according to the common idea. So what will happen? It will be very difficult to observe the color change at the end point. Okay, and but here color change detection is very easy. What you have done, you must have added drop wise your potassium permanganate from the burette into the conical flask, and you will go on adding till the reaction between potassium permanganate and more salt is complete. That is, till the redox reaction is complete. When redox reaction is complete, till that point your this medium will be colorless. Okay, and once the reaction between the two is complete, that is when redox reaction is complete, a slight excess of this will give you light pink color as the end point or the equivalence point. Okay, so here end point detection is very easy, but if you do the reverse, then in that case end point detection will be very tough. Therefore your unknown solution is taken as what, in the burette. Okay, otherwise titrant is taken in the burette. That is your standard solution. So in this reaction, how we are getting endpoint? In this reaction, your permanganate ion is undergoing reduction to Mn2 plus ion, manganese ion, and your ferrous ion are undergoing oxidation to ferric ion, which are present in the more salt solution. Okay, so this is when this reaction is complete, a slight excess of what you have, this will give you pink color. Why? Because in this reaction these two ions which are produced as a product, they are colorless, they don't have any color. So slight pink color we will get because of the very slight excess of permanganate ion. Okay, so the once you are very close to your endpoint, you should add your solution from the burette very carefully so that no excess of manganate ion is added, or the solution of manganate ion is added, so that you will get the error in your reading. Next question. Explain why fructose reduces Fehling solution and toluene's reagent despite the presence of ketonic group. Okay, fructose is having ketonic group. Even then it acts as a reducing sugar. So how is it possible? Okay, so reason is that in an alkaline medium, fructose rearranges to glucose, and both the fructose and the glucose, they are in equilibrium. So this is the reaction. This is your D fructose. It is having a ketonic group. This carbon is not having, it is not capable of undergoing oxidation as the aldehyde carbon. Okay, but what will happen, this D fructose will first get converted into enediol form. Okay, this is what we have here. We are having a double bond between first and second carbon, therefore it is ene, and we are having first carbon OH and second carbon OH, therefore we are writing diol. So this is enediol form, and this enediol form will again rearrange, or it will get tautomerized into two form, D-glucose and D-mannose. Okay, in case of D-glucose, this is the arrangement. So this carbon, that is the second carbon next to the aldehyde carbon, is having different stereochemistry if you compare the D-mannose and D-glucose. So basically D-fructose is in equilibrium with the D-glucose. Therefore this open chain structure, because of this structure of glucose which is in equilibrium with fructose, you will get all test that we get in case of reducing sugar. How will you distinguish between sucrose and glucose? Okay, glucose is what? A reducing sugar, and sucrose is a non-reducing sugar. So how will you distinguish between the two? Since glucose is a reducing sugar, it will give you positive silver mirror test. and sucrose, that is Tollien's test, and sucrose is a non-reducing sugar, so it will give you negative silver mirror test. So sucrose, as you know, it is a dimer of glucose and fructose, which are connected by a 1,2 glycosidic bond, and there is no free aldehydic or ketonic group in sucrose, therefore it is a non-reducing sugar. So you should know the reason why sucrose is a non-reducing sugar. Why? Because in case of sucrose, your first and second carbon, which are the carbon, anomeric carbon in monomer, they are involved in the glycosidic bond formation between the two monomers to give you dimer. Therefore, it is non-reducing sugar, or sucrose is not having any free aldehydic or ketonic group. Next question, what is the role of citrate ion in Benedict solution? Okay. In Benedict solution, we have done again this for reducing sugar. And what is Benedict solution? So Benedict solution is basically a mixture of sodium citrate, sodium carbonate, and copper sulfate. So these are the three substances: sodium citrate, sodium carbonate, and copper sulfate. They are present in Benedict solution. So they are asking, the question is, what is the role of citrate ion? We have sodium citrate, so we are having citrate ion in the solution. So what is the role of these citrate ion? So these citrate ion, they work as a complexing agent which will prevent copper 2 hydroxide precipitation. Okay, why? Because if you get a copper 2 hydroxide precipitation, then we will not be getting this Cu2O formation, and you will not be getting the positive test for sugar, that is, you will not get bright red precipitates. So to avoid this, your citrate ion will be preventing this copper second hydroxide precipitation. Okay, why? The copper second hydroxide will be prepared by the hydrolysis of copper sulfate. So this is the role of your citrate ion as a complexing agent. And this is the Benedict's test. You will take the sample solution, okay, 2 ml of sample solution, then you will add Benedict solution, then you heat in a water bath. Benedict solution is blue in color because of the presence of copper sulfate, and after heating in a water bath for 1-2 minutes, you will get a bright brick red color precipitate because of the formation of cuprous oxide. What are proteins? Proteins are the building blocks of all living organism. As you know that our muscles and body and most of the molecules in our body are made up of proteins. So proteins are large complex molecule composed of basic unit called as amino acid. Proteins are made up of monomer amino acid, and these amino acid, they are made up of carbon, hydrogen, oxygen, nitrogen, and sulfur. So amino acids are basically nitrogenous hydrocarbon, and sometimes they also have sulfur in them. These are polypeptide made up of alpha amino acids. So protein is a polymer which is made up of monomer, monomer is amino acid which are connected by peptide bond, and the polymer is called as polypeptide. So these are polypeptide made up of alpha amino acid connected by peptide bond. And what is peptide bond? Peptide bond is an amide linkage between amino group of one amino acid and carboxylic group of another amino acid. You know, amino acids, they contain, every amino acid contain an amino group and a carboxylic group. So amino group of one amino acid and the carboxylic acid group of another one combine together to give you an amide type of linkage, and this is called as peptide bond. So when two amino acid combine together, we call it as dipeptide. Okay. What is biuret test for protein? So biuret test is done to confirm presence of protein in the given sample. Okay. if you are not getting any test for carbohydrate, then next you will test for the protein. So in case of biuret test, the result will be that you will be getting a purple or violet colored as a result, as a positive result for the presence of protein. And how the test is conducted: so you will take sample solution, whatever sample is provided to you, you will make a solution, then you will add sodium hydroxide into it. And next step, you will add, after adding sodium hydroxide, you will add few drops of copper sulfate. Then you will mix these three together, and after mixing, if proteins are present, then you will be getting purple violet color like this. And if medium remain blue in shade, then that means it is negative test. So positive test should be the presence of purple or violet color. So if you are getting purple or violet color, that means your biuret test for the presence of protein is positive and protein is present in the given sample. Give functions of carbohydrate. Carbohydrate, they have variety of functions. They play important role in the body of plants as well as the animals or human beings. So carbohydrate, they are the biofuels. That is, the body of any living organism work on the energy, mainly energy derived from carbohydrate, and they provide energy to the organism and store chemical energy in the form of glycogen in the liver. So whatever extra energy is there in our body, it will be stored in the form of glycogen in our liver. And they are also the component of the cell membrane. So these are the two functions of carbohydrate. What is the difference between oils and fat? Oils and fat, they are having different melting point. Therefore, what we have, oils are liquid at room temperature while fats are solid at room temperature. And oils contain mainly unsaturated acids, while fats, they contain mainly saturated acid, that is saturated carboxylic acid. And here we are having unsaturated acid. What is the difference between saturated and unsaturated? Saturated carboxylic acid are those carboxylic acid which have only carbon-carbon single bond, while the unsaturated one are the one which have at least one carbon-carbon double or a triple bond. Mostly double bond we have. Name two tests for testing fats or oils. So the two tests are solubility test and the acrolein test. What is xanthoprotein reaction? Okay. So a reaction between a protein and concentrated nitric acid is called as xanthoprotein reaction. Okay, the term xanthoprotein is meant for reaction with concentrated nitric acid, and in this case you will get a yellow colored solution. So if you have yellow colored solution after treating with nitric acid, that means it confirms the presence of protein in the given sample. Name test for protein. So we are having, along with the names, I have given you the basic test also, just as a revision. So the test for proteins are biuret test, xanthoprotein test, Millen's test, and ninhydrin test. So first one is the biuret test. In case of biuret test, you will take sample. Again, sample should be taken in the form of solution. That is, you make an aqueous solution of the sample, then you add copper sulfate. If you are getting the violet coloration, that is medium become violet in color, that means protein is present in the given sample. Second, xanthoprotein test. Again, you will take sample in the form of solution, add concentrated nitric acid. If yellow coloration is there, protein is present. For proteins, your test for identification or confirmation are very simple as compared to the carbohydrates. Now, third one is the Millen's test. In case of Millen's test, sample again in the form of solution is taken, and after this, you will add mercuric sulfate in the presence of sodium nitrite and sulfuric acid. So these are three reagents in which we call as Millen's reagent: mercuric sulfate, sodium nitrite, and sulfuric acid. You will get a brick red color or the bright red color solution. Again, protein confirmed. Ninhydrin test, again sample solution, and you will add pyridine solution of ninhydrin. You will get a violet colored solution, again protein present. So 4 tests are done to check the presence of protein in the given sample. Next question, why few drops of dilute sulfuric acid are added while preparing standard solution of more salt? So this is done to prevent hydrolysis of ferrous sulfate. What is permagnometry? Okay, the titration you have done, it comes under the heading permagnometry. So what is this? Redox titration involving potassium permanganate as oxidizing agent are called as permagnometry. In your titration, potassium permanganate solution was acting as an solution of an oxidizing agent, while more salt solution was acting as a solution of reducing agent. Why is sulfuric acid suitable for permanganate titration? In your titration also you have added sulfuric acid. So potassium permanganate act as an oxidizing agent in acidic medium. Okay, you know that few oxidizing agent, they need a particular medium for their property, that is oxidizing property. So if acid is not used, your potassium permanganate will be oxidized to manganese dioxide, that is plus 2 oxidation state to plus 4 oxidation state, and you will get a brown precipitate. Okay, so when you are doing titration, if you are getting something brown in the medium in conical flask, that means you forgot to add sulfuric acid. So be very sure when you are doing your titration and when you are preparing your solution, in case of your titration, you have to add sulfuric acid as guided by your teacher. What is normal solution? We have done standard solution and primary and secondary standard stock solution. Now new term, normal solution. A normal solution contains 1 gram equivalent mass of solute per liter of solution. So when solution is 1n, it is called as 1 normal. That is when normality of a given solution is 1, that means it is a normal solution. Okay. Why is it customary to read the lower meniscus in colorless and upper meniscus in highly colored solution? So in your lab, you must have taken a reading of your burette, and that too carefully. That is, we have to make very clear observation. Level of your eye and the burette or the reading should be matching, so that you will not get any error in writing down the reading. And there you have to check the meniscus also. So in colorless solution, it is easy to read the lower meniscus. This is the lower meniscus. Okay. So why? Because it is visible. You are able to see with your eye clearly the lower part, that is liquid forms such type of curve when filled in a tube. So this lower part is called as lower meniscus. So in a transparent solution like water, it is very easy to read the lower meniscus. Okay, but if the solution is colored like potassium permanganate solution, so if it is colored solution, the lower meniscus is not clearly visible. Okay, here this part is not very much visible. Therefore, for colored solution, we read the upper meniscus. So this is all for today. Thank you. I hope these questions and their solutions are clear to you.